Hi, today we'll talk about Hashicorp Vault, which is a great tool to encrypt secrets and to share access of machines and secrets between applications. Hashicorp is the company behind Vault, so you can see its products here. It has many great products like Terraform, Consul, Vagrant. Today we're gonna focus on Vault and the installation of Vault in a virtual machine and how to use storage in the Oracle Cloud and how to integrate with Oracle Cloud Service. So Vault is used by many companies. It protects critical systems and customer data with encryption. It has a lot of integrations, for instance, to authenticate SSH and keys and provide a way to rotate the keys. You can automate this secret delivery directing on your applications. In the series we'll do a configuration in Kubernetes in order to retrieve the secrets without modifying applications. It's a very robust application. It's an open source application. You can start for free and you can use in the cloud using a service provided by Hashicorp, and has a good documentation. But I assume you already know the basics of Vault here, because we're gonna install and unseal the secrets and for it automatically. So the basics of Vault is the key management, the secret management, and the encryption servers. You can store, access, and deploy secrets across applications, system, and infrastructure. You can encrypt servers like credit card numbers. We use just the secret manager here. The thing you need to know for a basic introduction is that Vault itself do not have access to its own store. Its store is encrypted, and once it's locked or you restart Vault, it won't have by default access to it because it's encrypted by default. So you have to be an operator to use a key to unlock the Vault. That's how much secure is it. But in the case of this video, we're gonna use a auto unseal key. So we're gonna store the keys for the Vault for the unseal, which is by default are 5 keys. So you need at least 3 keys to unseal a Vault. It's a shared algorithm. The intuition of Vault is that you create the shared keys and you spread them between people of trust, so you don't have one key, all the keys with just one person. But when you automate and you rely on the Vault, this is not so good, because if Vault restarts, it will seal itself, and you need a manual intervention to unlock it. In this video, we're gonna see a way to do that automatically in secured fashion. We're gonna use some concepts of Vault, and we're gonna use the seal unseal concept. When you use authentication, we're gonna authenticate with the Oracle Cloud itself. I'm gonna use tokens. I'm gonna use policy to configure how the authentication works. And you're gonna use the concept of storage, because we storage in a bucket all the information of Auth. So your architecture for this video is that we will have a Vault VM that will auto-unseal itself using a Vault AAS key. The Vault VM will storage its state in a bucket in the Oracle Cloud, and we will create some group in the Oracle Cloud Identity Manager called Vault admins that will have access to Vault itself, so you can authenticate using tokens from the Identity Manager of Oracle. And Vault, in order to access the key, it will have a policy, a Vault policy, which will allow a dynamic group to permit access to the key, and to permit access to the buckets it needs to write and retrieve information. Also, the dynamic key will permit access to the Vault instance to identify and to authenticate with the Oracle Identity Servers. This dynamic group will referentiate the VM instance, so when you deploy the Oracle Cloud CLI, you don't need to provide the credentials for it, because it will retrieve the credentials from the environment of the VM. First step is create the instance. So in the Oracle Cloud, you can go to Compute Instance. Here we will create a VM. I'll call this Vault Test. You can select the Linux you want. I will be using Oracle Linux here. Vault is a lightweight software, so you can use the microshape for testing, and you don't need a virtual machine with too much resources to run Vault. I will run Vault in the private subnet, so I don't want to expose Vault to the internet. I'll let the default boot volume. Not using transit encryption because it makes the VM a little bit slower. Don't need anything in the advanced configuration, and just create. Heavy outer limit, so we change the Auth free shape. So I have to select a different shape because of I ran out the limit of the free shapes. So we will wait for the machine to start up. Okay, it has started. So I will copy the private IP address, and I do have a VPN between the private subnet and my machine. So we just make it work here. So I'm on my VPN now, so I can access this IP address. Okay. Now we can install Vault. We can go to the documentation, installing, using the package management. Can go to get started installing. Linux. Center as Red Rat. You need to install Unseal. So you add the REPL. And it just install Vault. So do not start up Vault yet. You're gonna need to configure a lot of things here. You can verify the installation using Vault. Now we start configuring Vault. First thing we're gonna need is a key to unlock the Vault. So you go to our cloud, identity security, Vault. If you don't create a Vault yet, you create one here. A Vault is storage for keys. So I have one here. Generate a key. You can use a software key which is free. And Vault test key is a symmetric key. You can select the key shape and use it 256 bits. Okay, after the key is created, go to the key, copy the OCID, go to the Vault server. You gonna edit the Vault configuration. And this file. And we need to add the API address here. We'll listen to all the to all interfaces here. The UI, it's enabled, UI true. I'm gonna add the cluster name. And I'm just gonna configure some things like max time live, and default listen. And change the log level to info. Now I need a listen. I will comment the storage gonna reconfigure later. We need a listener that we use in all interfaces here, and we created a TLS certificate in the last video, so this is where we're gonna use, but I just comment here for now. I'm not gonna use. So I will use TLS disable here. And here's where we gonna configure the Unseal plugin. We need to use Seal. Use Seal OCI KMS, and I will provide Auth tape API key to false because we're gonna use a dynamic group to authenticate in a policy. We need to configure crypto endpoint. The endpoint, you can, in the vaults, you select your vault and you copy the crypto endpoint. And we need manage endpoint. The managed point is also here. You can copy it. And we need a key ID. Which is the ID of the key we generate. So we go here, about test key. We copy that, the OCID. And that's it. Now, in order to vault to access the key, we need to create a dynamic group. So in Oracle Cloud, we go to Identity Security. We go to Overview, Users, Dynamic Groups. We create a dynamic group. I'll call it Vault Test Dynamic Group. You added rule here. So we're gonna add a rule here that will have the instance ID of, and we need the ID of the instance. So we can go copy the OCID. And you just create. So what this dynamic group does, it selects the instance ID. So it will create the group with the machine inside the group. Now you go to identity and security, identity policies, create a new policy. I will call it Vault Test Access Policy. Go to the manual editor. So we're gonna add a policy here that allows the dynamic group, which is the dynamic group we just created, to use keys in the compartment ID. This is the OCID of your compartment. You can access this, identity and security compartments. So I select this compartment. This is the compartment where we create the keys. So you can copy the OCID here. And you provide a conditional. This is where the target key ID is equal to the ID of the key you created. So we copy the key, vault, and vault test key. We copy that. The second state we need is to allow the dynamic group to access the secrets. We allow the dynamic group to use the secrets in the compartment ID, the OCID of the compartment. And that's the policy we need to create. We need to add a description. Okay, now the seal can work. Now we will configure the storage. So to configure the storage, we use the OCI plugin. So put storage OCI. We provide out tape API key false. So we use the dynamic group, and we use a bucket name to storage. I will add this name, test vault, and I will add test vault for the lock bucket name. So when you use a highly available vault, it will lock use a storage for lock proposals. This is the name of the buckets you're gonna use. You also need the namespace of the bucket. So let's create the buckets. You go to the Oracle Cloud Storage and buckets. You create a bucket. Use the test vault here. So just create a bucket and a test vault lock bucket. The namespace you can get from any bucket. So you copy the namespace here and you put here. Now we need some policies to access the bucket. Go to Oracle, Identity Security, Identity Policies. I will edit the policy we created and we'll add more statements. The first statement is to allow the group to manage objects in the two buckets we just created. So allow dynamic group, name of the dynamic group, to manage objects in compartment ID, and where there's target, it's any of these names. So the vault test and vault test lock. The other statement we need is to allow the dynamic group to read buckets in the compartment ID that we have the buckets created. So just save the change. And that's it. Now we need to install the OCI command line. We use that using pip3 install OCI CLI. So it will take some time. So it has installed the OCI. Now we can start the vault. And enable in the startup. Let's check the status of Vault. It's running. So we just export the vault address to the local address. And then we're gonna need the operator saving the keys to a file. Well, the bucket's name is not correct. Let's fix that. Test vault. and the name is correct, so it must be something with the policy we create. So the bucket name is wrong here. Just try again. Okay, now it works. Took some time to the policy to update. Now that we have the keys, we can unseal vault. If we check the keys, we need to use 3 keys. So we can just copy a command here to run through the file and use 3 keys to unseal it. So the command, it's a little bit wrong here. Let me fix that. So we unseal the vault. Can use the token to login. We're just scraping the token and exporting to a variable. The token is also in the key.txt file. Now we can log in. We are logging in the vault. We can see the secrets that are available in vault, the secret backend. We can test the vault unseal process by restarting vault. And if we check the service logs, so see that you have successful unseal the vault. So if we run the vault secrets list again, we don't need to unseal vault, so it will survive a restart. Now, if you want to authenticate in Vault using your Cloud credentials, that's the way you do it. You enable the OCI plugin, the Auth plugin, and you need to configure the OCI with your home tenants ID. Get your tenants ID from your profile. Go to your tenants, copy the OC ID and you configure the tenants. It does put that there are requests passing the data file in the Auth OCI config. After that, we need to create admin policy. We will grant users from Oracle Cloud Group the admin policy. So just giving on all parts the all capabilities. Need to write the policy called vault admin. So we upload the policy called vault admin. Now we need a rule The rule will associate the token, the vault policy, with a OCID go to Identity Security, Overview, Users, Groups. I will put the Vault admins groups that I created. And I will also put the dynamic group of the machine itself. So just copy the OCID. And gonna put the vault rule ID, the file, into a rule, into the URL out OCI rule vault admin rule. Now we can test the logging. It's the vault logging method OCI out tape instance that means gonna use the dynamic group to authenticate using the vault admin rule. We need to add a policy to the dynamic group so we can authenticate with the Oracle Cloud identity domain. So in order to allow Vault to authenticate in the Oracle Cloud Identity Manager, we need to provide a policy. We go to Identity and Security Policies. This policy needs to be in the root compartment. So select the root compartment here. Create a policy. I'll call Vault Test Access Identity. Allow Vault instance to authenticate with the Oracle identity. So add a jitter here. So the policy is we allow dynamic group we allow the dynamic group vault test dynamic group to authenticate and inspect in tenants, and we allow the vault test dynamic group to inspect the group membership in the tenants. So we just gave a minute to the policy to be up and running, and we should be able to log in using the OCI method. Now we just log in and we receive the policy vault admin, so we can vault secrets list and we can get secret on any path. Now to complete the configuration, you're gonna create a dev policy. We will create a dev policy. As an example, that in the secrets, in the path secrets, we have all capabilities except for Suru. So you create the policy. Now we enable the secret. We enable secrets again. Add the path secrets, and the policy we created just gave the access to the secrets to this secret. And we now create a dev rule. And we need to provide one group here. You can just create identity security and the users groups. You can create a group called vault dev. I will add myself to the group. We'll copy the OC ID for the group we put here. And just pass the dev rule using the token. So we create the dev rule. Now we can use a machine with the OCI installed. So I have the OCI. You can test the OCI using the OCI IAM user list. So it's working. I already authenticate using OCI. So now I can export Vault to use the Vault IP address. I have already installed the Vault command. So I can use Vault login OCI. Now the out step we're gonna use the API key, and with the whole we're gonna use dev rule. Just remove the slash. And there is a bug with the authentication of the OCI using Vault, and is this bug in the GitHub. The bug refers to the seal of OCI without using API keys. Is the out step API key equals true, but it's the same bug for the authentication. So it will not work, the authentication, with the API key, but we can test in the vault if we can log in with the dev rule using the instance as the Auth tape. So I can authenticate because my dev rule do not allow me. Because I'm not in the group, so I need the instance not in the group, so I have to put, to test, I have to put the dynamic group in the list. And now I can just try to log in again. And now I log in as a dev, and my token cannot list the secrets, but it can list the secrets from the secrets path. KV get mount secrets some path. So there is no valid font, but we can just put a valid here in the path, like foo equals a bar equals bb, and we can get the secrets from the path. Now we have the two keys here. Now that we have Vault up and running, we should note that there's a lot to do to integrate Vault with Oracle. What if we could automate most of the steps we just did? And we can do this with Terraform or using Pulumi. Pulumi is a software tool to manage infrastructure that I highly recommend. You can use a diverse number of languages to work with in TypeScript, like Python, Go, C#, Java, and Yum. And I like to use TypeScript for the projects. We can do in Terraform, but I'm using Pulumi here, and we share with you the Pulumi stack that we gonna deploy. So Pulumi is a free service. You can just sign in for its service, and you should create a stack. So once you sign in, you've been presented for a dashboard. You can create a stack, a project here. We can create a project with a cloud provider. You can use AWS, Azure Cloud, and Kubernetes. And you choose your language that you wanna work with. But we're not gonna create the project for here, because Pulumi has a little bit of confusing integration with the with source control. So if you create a project here and you upload the code to your source control that you integrate in the settings, you can use GitLab or GitHub, and you could duplicate the project. So what we're gonna do, we will create a project here with the Vault CI, and so we can check the code here. We have two folders here. One is for Ansible that we will run after we create the resources. Another is the Pulumi project. The Pulumi project has a Pulumi file, which is the main file. So I just wanna create here the name Vault. I'll just give a name here, Vault installation. So Vault installation in the Oracle Cloud infrastructure. I made some adjustments in the code so we can use in the code, we can use the await, and we can use async and wait keywords. So when we need to get the availability zones, so it's an async operation, so we need to wait for it. And so I made some modifications in the TypeScript for it using the target ESMest. But that's just that modification that I made. So we modify the package.json. So Vault installation, and we gonna use the Pulumi OCI dependence, so we can provision Oracle Cloud resources, and we create a Pulumi test, which is the environment we're gonna start. So after that, I would just give it a init. We need to add all the resources. First, I want to just see if there are any sensitive information here. I don't think there is any sensitive information, so we can add everything. So Pulumi is integrated with my GitLab, so I will create a new project here. You can use GitHub if you want. I'll pick a namespace here. Vault OCI. installation. I will not initialize the project because I already commit the project. So we need to add a remote, and we need to push the code. After that, we should see a stack here. Just gave a few minutes, so the stack it's updated. I'm going to refresh GitLab to see if it helps. We need to initialize the stack. Stack name dev, and let's see if the stack's now here. Okay, there is the stack here in the Vault OCI installation. Now that we have the stack here, we need to configure the stack. We need to add some configurations to the file. The configurations we're gonna need are the OCI region. So you can add a configuration using polemic config set OCI region with the region that you have. So it will alter the polumi-dev file with the configuration. So just add that. We also need to set the tenancy ID. Polumi OCI tenants OCI ID. The tenancy OCI ID you get from your profile. Just copy that. And you can add a secure flag in order to encrypt this information so you can share the configuration file in your version controls. It's not secure, it's secret. We also need to provide a bucket name. Please note that when you add 2 dots, you are configuring a plugin. So the plugin name, 2 dots, and the config key. When you don't add 2 dots, you are configuring the you stack in the Pulumi. So here in the stack, we have the compartment ID, tenancy ID, and root compartment ID as required information. So you have to add that. So using Pulumi of this, you can add your configuration that way. You can see your bucket name in Oracle storage buckets. You go to any bucket and you have the namespace. Now, bucket namespace need to configure the compartment ID. In this case, I'm gonna use another compartment, so can be identity secured compartment. I'm using a test resource compartment, so just copy that and add the secret. You also need a region, but the difference between these two regions, because one is used in the stack, the other used in the OCI plugin. So region, which is the same. We also need a root compartment ID because we're gonna create some resources in the root compartment. So the root compartment, you can be seeing the compartments is this one. So just copy that. You can add a secret as well. We will also need SSH public key, so we can connect to your VM. My public key is that, so it's the content of the public key. And you're gonna need the tenancy ID also in the installation. So you could get your tenancy ID as the same way and use a secret, so you can share in the VS Code. So after the configuration, we can check the Pulumi installation. We have here the OCI plugin as a dependence, and I just modified the test code file so we can use the target ESNash, because we want to use asynchronous communication, so we can get the servers, the current servers in the region, and we programmatically filter the servers so we get the all servers network when we create a service gateway. And here we have your resources. We have Virtual Cloud Network, Internet Gateway, a Net Gateway. We will reference the Virtual Cloud Network here, the ID of the created Virtual Cloud Network. And we are using the service ID we just find. We create a NAT route using route table. We create an internet route and security list so you can communicate with your servers. This security list is wrong. And security list for the public subnet, for the private subnet. And we create the subnets itself, the private and the public one. Please note the DNS label so we can reference the machines internally by DNS names. We get the placement config using the availability zones we find in using code here, where we get the availability zone name and the subnet ID, so we can use this in your configuration here. We create a new instance. We set the shape of the instance, the shape config using 1 GB of memory and 1 of CPU here. You need to add the image as a source ID. You get the ID of the image in this page, docs Oracle image. So you select the image here. Suppose we want Oracle Linux. So you go to the Oracle Linux for the AMD 64, read more, and you select the image for your region. In this case I'm using this region, so this image just add here, and you create a vault, and using a Unseal key secret, and everything else is the bucket's name. You are creating the rules, the dynamic group, referencing the ID of the instance we just created, and you're creating a group for vault admins, and you are exporting some information here: the vault IP address, the public IP address, and the key ID, and some other information you're gonna need after the provision of the servers. So if everything goes well, we can use Polymer up. We can use preview to see what we're gonna create. You can check everything you will create, and use the Polymer up to create the resource. Say yes. So if everything goes well, we will see all the resources created. Okay, everything is created. We can connect to your Vault VM through this IP. Okay, it's working. Now, let's see the resources we just created. We have networking. You just see test resources. We have test VNC, private subnet and public subnet. And we have your DXP outputs, your net gators, your service gators, security lists, and we have in the storage buckets, the two buckets we're gonna use. We have the policies, identity, security, all the policies we saw. We have the Vault instance policy, everything configured correctly. Also, you can access the bucket, can access the Vault key. We have the key and identity, security, Auth. This is the Unseal secret created. And we have your computer instance running. Now that we have the Vault with everything configured, we need to post provision. The post provision is also automated. We saw in the Ansible, we need to work with our inventory here. So we add the IP address of the server. It will connect using OPC user. And we have, for all Vault servers, we have a rule that will configure the file. We'll configure the file with a certificate. We'll use the seal OKMS. We configure the storage. So we just need to provide the group values with the correct values. So we need to take the endpoint for the bucket, storage buckets, bucket name, Vault bucket lock, namespace the same, it's that information, and we need the crypto endpoints. Let's see if this is the same. Identity, security, Vault, Plum secrets. I think it's the same, but let's copy that. Cryptographic endpoint. The OCID key is different. I think we provide that as we export that. We export the endpoint, but we not export the. Now that's the Vault key ID that we just created. So use that. Manage endpoint is also exported here. So after that, we run the Ansible command. We run the Vault service. and it will install Vault and configure everything for us. It will configure some firewall ports and will install the Hashicorp Vault. It will configure this server. It will add certificates, SSL certificates. It's on let's run again. Then we have, now if we go to the server and see the status of Vault service, it's running. So we add a certificate, so we need to use one of the names of the certificate. So I'm gonna use, so the certificate has vault kubernetes.com. Need to read sudo. So we can vault in it. Okay, we have the port. We need a port here with 8200, and we can do the init. We're successful init the vault operator, and we can do everything we did in the previous instructions to initialize the vault operator. And we can get the keys, vault Unseal, use 3 keys, and we can use the token.
There we have it. So with a field configuration and 2 commands, we create all the resources necessary for the Vault and the integration with Oracle Cloud, and we provide an installation of Vault. So that's it. Thanks for watching.